I would like to welcome you all this evening, this afternoon, and this morning. Thanks everyone for joining. This is our Diffblue Cover 101 webinar series where we run through a technical demo. And what we're looking to do today is take you through and really walk you through how developers can maximize unit testing efficiency using Diffblue Cover. And more widely, we're interested in how AI can be used to augment developer output productivity and velocity. So my name is Zoe Laycock. I'm product marketing lead here at Diffblue, and I'm responsible for product and developer marketing. And I'm going to hand you over now to our senior solutions engineer, Animesh, and he'll be piloting this webinar and taking you through the technical demo. So over to you, Animesh.
Thanks, Zoe. Hello, everyone. I'm Animesh. I'm a software engineer. I come from a software engineering background myself. And today I'm going to walk you through what made us create Diffblue, what it does for you, how you scale the power of AI and automate unit testing so you can accelerate your release cycles. So without further ado, I'm going to start the webinar. If you have any questions, please drop them in the Zoom chat and we'll pick them up after the demo. The demo itself should take about 20-25 minutes, so we'll have plenty of time for Q&A. So please keep your questions coming. So I don't think it's going to be a surprise for anybody on the call here today if I tell you the unit testing takes up far too much time. It's a laborious process. It's very error prone, and no developer, including myself when I was in software engineering, wants to actually write unit tests. We know for a fact that one of our customers, Wells Fargo, before they adopted Diffblue, was spending $30-40 million a year just on testing alone. So it's an expensive exercise, but it's a vital engineering process. So we at Diffblue were grappling with this question as to what could we do to address some of the fundamental problems with unit testing. How could we test our applications more comprehensively, but make it a lot easier for developers to do so? How could we continuously improve code quality while ensuring that the code that we're writing is also resilient and well tested? Because as it's taking up too much developer time, and unit testing often gets relegated when people are under the cosh and deadlines become important. So we asked ourselves a question. This seems like a problem that's ripe for automation. So what's happening out there? Let's take a stock of our options today. So if you look at the landscape today, we have, in terms of how we go about writing unit tests, we have a few options. We could write the test ourselves. We've been doing that for a few decades now. Developer-written tests are generally readable, although I've seen a few interesting ones. They tend to reflect the intent of the code, and well-written tests also do a good job of self-documenting the application itself. The only real downside with dev test is the enormous amount of time it takes to write really good high-quality tests. In the past few years, we've seen the rise of AI code assistants. So these tools are built on large language models, and they try to match the words in your code to the words in their model and return some output back. Now, this output may or may not be valid code. It may compile, it may not. If you were after a unit test, it may give you a unit test that may or may not run, and if it runs, it might not be targeting the right code branch. So what we find is that developers often have to take the output which these two tools produce and massage that into the final outcome they're after. So they do save you some time. They do give you a productivity boost because you get this stellar boilerplate right off the bat, which you then edit away to get to what you wanted to. But it's not a completely automated process. We ask ourselves at Diffblue, could we marry these two worlds? Could we take the scale and automation enabled by AI and marry that with the high quality unit tests that developers write. It turns out that we could, so we did, and we patented it. We call it Diffblue cover, and it writes and maintains unit tests for your Java and Kotlin applications. It does so completely autonomously. There's no development intervention required, and it ships in two forms. There's an IntelliJ IDE plugin, which helps you write and update tests as you're coding in your IDE. And there's a command line interface that sits in your CI pipelines and makes sure that no change, no commit, no PR goes untested. Let's have a look at the whole application. So on my screen here, you'll see in the right, I have my terminal, which is where we're going to use the Diffblue command line interface. I've got a sample application on the left, which is where on which we're going to try a cover on. To start off with, I'm going to use the Diffblue cover CLI to ask Diffblue cover CLI to go and write test cases for the whole application in one go. And to do so, all I need to do is write that command dcover create at the root of my project, press enter, and walk away. I don't need to sit there and babysit it. It's not a code suggestion tool. It's going to go, analyze the application, and write a bunch of really cool tests for me. While it's doing that, let's have a look at the application, what we're testing, how we're going to go about testing it. So in my browser here, I have a sample application developed by the Spring Framework team. It's called Pet Clinic. I'm particularly interested in this fine owners pet form we have here. It allows me to search for pet owners by their last name. It's got a few distinct behaviors, and I'm wondering if Cover will be smart enough to pick them up and then write some really good regression busting test cases for them. The first one is if I do not specify any input and do a search, I get it returns the whole database back at me in a paginated list. If I use a last name that's shared by multiple pet owners, I get shown a paginated list with all the Davises, and I can click through to their contact details from there. If I use a name that only occurs once in the database, there's a neat little optimization that takes me straight to that person's profile page. So we skip that paginated list. And finally, if I use a name that's not in the database, such as mine, I will just get shown a not found message. So very simple, standard MVC style application, model view controller, a form querying a database, and we have asked Cover to go and write some tests for it. As developers, when we were writing tests for it, we will make sure that all of these 4 different cases were covered so that even the smallest change in the behavior of the application is captured straight away. Sorry, I thought I wasn't sharing my screen. So let's have a look at the code that powers the search function. This method is the one responsible for driving that search behavior. We can see that it's got a few different code parts. That's the branch that does the broadest possible search because we've not provided any search input. That's our not found case. The last one here shows us a paginated list for all people with the same last names. And finally, that neat little optimization that we talked about, which did a redirection rather than doing a pagination. Cover in the right in the terminal here is going ahead and writing tests for the application class by class. While it does that, let me walk you through how we go about writing tests. So we use a machine learning technique, which is very different from large language models. It's called reinforcement learning. We're not looking at your plain text source code. We look at the Java bytecode of your application and analyze it to find all of the methods and classes that make up your applications. Once we've identified them all, we'll pluck a method and run it in an isolated sandbox to observe its runtime behavior, all the effects and side effects it causes when it's actually run. That analysis allows us to predict an initial candidate unit test for that method. We'll then run that test against the method and measure things like code coverage, how readable the test case is, and a few other secret metrics that allow us to answer the question, is this a good unit test? If it is a good unit test, we will commit it to the project and move on to the next method. If it's not, we discard that test method, predict a better one, and keep going through this learning loop thousands of times a second until a great set of unit tests have been written for the whole application. And we're able to do this about 250 times faster than a developer and 60 times faster than Copilot and other LLM-based tools. Coming back to our terminal, I can see that Diffblue has finished writing tests for our owner controller class. So let's have a look at what it has produced. The first thing that will strike you is that Diffblue has gone ahead and written a whole valid JUnit test class for our method under test without us even having to come in and edit anything away in that test file. And we can see that all of these tests will run by asking the IDE to run them for us. So we can see the code compiles, the tests run, they all pass, and we managed to get nice 95% coverage right out of the box in a matter of seconds. So it's all very great, but coverage is no good if the tests we have written can't help us catch regressions, because that's the main purpose of unit tests. So if we look at the test cases that we have produced, Cover has written 4 different test cases for a process find form method. The first one takes care of the case where there was no search parameter provided, so that does the broadest possible search and returns the whole database back. The last case is when we are looking for a name that doesn't exist in the database, the not found case. Second test case is where we have a single item in our search result and we saw a redirection happening straight to their profile page. And the last test case is when we have multiple items in our search results and we saw a paginated list. So if we focus on these 2 test cases, because they have a very slight change, very nuanced change in behavior, but Cover is able to pick that up. So this test case in its entirety, when I look at it, the first thing that strikes me is how readable it is. It's written just as a developer would like it, just as you and I would write, using the classic arrange, act, and assert pattern. It uses the Cover smart enough to understand how the custom data models in your application work, how to instantiate them. It can create some synthetic test data out of the box. You can also give it test data if your application relies on some specific proprietary test data to work. So it's created some test data, set up the application, and then using the mock MVC framework to drive the search behavior and asserting on what it saw when it ran the method. And what it saw was a redirection happening when there was a single search result item. And that's exactly what we saw as well. So far, it matches what we've seen and in the code and what we've seen when we run the application itself. Looking at the second test case, more test data creation. This is the case when there are multiple people in our search results, and what we saw when we ran the application was a paginated list shown to us. Cover has created these test content for us, started off the application, and then it's using mock MVC again to drive the search behavior and asserting on the pagination that we saw as well. So the application, so all the tests written work. They reflect the runtime behavior of the code without any intervention from me as a developer. All I had to do was go in my terminal and write dcover create and walk away. Let's see what happens when we change our code. So I'm going to take this redirection optimization out and replace it with the standard pagination behavior. Now at this point, if my test suite is written well, so one or more of the tests should fail to alert me to the change I've introduced. Because if I have a test suite that just always passes, regardless of what I'm doing in my code, then it's not really a good test suite. Lo and behold, what we do see that the test process find form 2 here, it does fail. And we look at that test case and what it's asserting on. That test case is when we had a single item in a search result. it was set up to expect redirection. We've now moved on and made a change to the code where that redirection is no longer happening, and that test case is failing, and that failing is a signal to me as a developer that the behavior has changed. Now, at this point, as a developer, I have a question to answer. Was this intentional? Am I trying to change how this application behaves? If that's the case, all good. If it isn't, if I was trying to do something completely different, and this is an unintended side effect of what I was going for, then this is a regression I've introduced, and Diffblue Test Suite has alerted me to that regression right in my IDE. So if this was a regression that I had introduced, all I would need to do is just undo my change, and all's good with the world again. But let's say I'm actually trying to change how the application works. I don't like redirection. I just really like to see pages everywhere. In that case, I can use the Diffblue IDE plugin to update the test cases for this method. You download the IDE plugin by going to IntelliJ IDE store and search for Diffblue cover. And you can it comes up in the search results, and you can download it from here. Once you do so, you get this nice little Flask icon in your IDE when you open a Java file. You can click on that Flask icon to get to ask Diffblue Cover to write a unit test for a method, a class, or a whole module in one go if you need to. I'm going to go to my failing test here, click my Flask icon, and ask Diffblue to go and update the test to reflect this new feature I've introduced. Let's see what it does. One of the things that Diffblue does before it proceeds to writing tests for your application are some environment checks. We call these pre-flight checks. And these environment checks help us make sure that whatever code that Diffblue will be given to process will be compatible. So we will look here in our pre-flight checks, we're looking at things like the build system that the application is using, the JDK it's set up with, which application framework your code relies on, the testing and mocking frameworks, all of that. And we're making sure that these frameworks are not just something that's compatible with Cover, but also mutually intercompatible as well. So if you're using Spring Boot 3 and Spring Boot Test 9, for example, those two libraries aren't compatible, it won't work. This will get flagged when we do our pre-flight checks. But if everything checks out, that means that Cover can work with the application you've given it, and we'll go ahead and write some really good tests for it. The reason we do these pre-flight checks, particularly around the versions of these libraries, is so that when we go and write tests for your projects, we're going to use these exact versions, which come from your project configuration, so that the test produced can neatly fit in your existing setup without requiring any extra configuration. So it's a zero-touch configuration, click a button, get a test, it just works. So we can see here, Diffblue has finished updating our test. So if we go back to that test case, which was failing previously, I can see the assertion has now been swapped from a redirection to a pagination. If I run this test, it was previously failing, it no longer will. That's great. Let's run our entire test suite to make sure that I've not introduced a regression with this new behavior. So all good, excellent, 95% coverage. And I've just introduced a code change and made sure that's all covered for as well. So that's how Cover allows you not just to write unit tests in your command line, but also within your IDE using the plugin. Every time you're making your incremental code changes, click a button, get the best kind of test you can for the code change you've made. But how do you scale it? You scale it by putting Cover in your CI processes. The command line interface that I've run here on the side can just as easily be configured for any of the CI platforms they're using, be that Jenkins, GitLab, GitHub Actions, Azure DevOps, any technology that can run a CI pipeline can run Diffblue Cover. to use the CLI to scale the power of cover across your teams and to ensure that no code change, no commit, and no PR goes untested. I'll show you how you can set that up and what that looks like using GitHub Actions, because it's a one-click setup, but the principle works just as well for other CI platforms. We have out-of-the-box integrations for GitHub Actions and GitLab, and others are in the pipeline as well. To use the Diffblue cover pipeline integration, you can go to the GitHub Actions Marketplace. Actually, let's do that. So you go to the GitHub Actions Marketplace and search for Diffblue cover. You'll see that in the search result. You click that use latest versions and give you the instructions on how you can integrate Diffblue into your existing GitHub Actions workflow. I already have a repository where I had set this up not too long ago, only an hour before the demo, and where I made the exact same code change that I've shown you locally. So I swapped my redirection business with pagination. I did not generate the test case locally, so I could show you the how the CI works. And once I open my pull request, Diffblue cover kicks into action, sees there's been a code change, runs existing tests. The tests which do not pass anymore, they get removed, exactly how we saw locally. Some of the tests failed, alerting us to a change in behavior. And then Diffblue cover is smart enough to look at my git diff patch, the change I've made, map out all the parts of the application which are affected by that change, and will go ahead and update all of the test cases that need to be updated to account for it. And it'll push those changes as a new commit to this very pull request that I've opened. So as a reviewer, you are looking at two things. You are looking at the code change that I've made and the resultant change in the behavior of the application as shown by the assertions. So here I can see before I had redirection happening in this test case, now that has been swapped out with a pagination. That is exactly what my functional brief was. So my code works the way it's supposed to. It's written in the style that we want to write it in. So it works the way you want to, written the way you want to, check, check. We'll review, we can merge this pull request and get it out to the customers, knowing fully well that it's been completely tested and reviewed by our developers. If there was a discrepancy in one of these things, so maybe the code wasn't written the way we wanted to, or the assertions were reflecting the runtime behavior that doesn't really reconcile with our functional requirement. In those cases, you will reject the pull request with the reason, and the engineer has to take stock of what has gone wrong, go back and update the pull request, come back again and see if the Diffblue tests are now finally reflecting the feature that we're after. So that's how cover scales across organizations, across teams, and help you effectively make test writing an automated endeavor part of your CI furniture. Finally, we asked cover to go and write test cases for the whole application, the pet clinic. It managed to find about 100 methods across 23 classes in this application. And it's gone ahead and written 82 tests for them. 82, a unit test typically takes about 15 minutes to write on average for a developer. 82 tests would have taken a developer a full week of full-time test writing effort. Diffblue has done that for you in 4.5 minutes, and each of those 82 tests are just as complete, just as valid, and just as regression busting as the ones I've showed you. And that's Diffblue cover in a nutshell. I would recommend you. So just to wrap up how what we saw, we started off with our mainline branch and used the command line interface to write some baseline tests. Then we made a code change locally in the IDE and saw how we can use the plugin to update our tests locally. We also saw how we can use the GitHub Actions integration to automatically run and update the unit tests as they need to on every pull request in our repositories. The code review, once Cover has gone ahead and updated all your test cases, the code review becomes that point of manual review where you not only validate the change the developer has made, but you also see if the test cases are reflecting the behavior that you were after. So this is the point, the natural point in the software development lifecycle where you review both what the developer was up to and what the Diffblue was up to. If there are any if something doesn't match, you reject that pull request, the engineer has to go and update the code, and if everything reconciles exactly as you expected, then you approve the PR, you deploy that change to your customer, knowing fully well that everything's been tested and covered for. And that's Diffblue Cover in a nutshell. It allows you to not just write unit tests, but also maintain them at scale automatically for every change, every commit, and every PR. It's completely autonomous, so I never had to go into any of the test cases produced and fix them to get them to compile or fix them to get them to produce the right assertions. And most importantly, because we have a computational understanding of the code, when we're not able to write test, we will leave behind what we call testability insights, messages to the developers as to what they could do to make a particular piece of method more testable. So it not only writes tests for you, it also makes your applications and code bases more testable over time, iteratively. It's a very iterative tool, which is why it fits so nicely in the CI pipelines, and it takes care of your, it increases your coverage over time and makes sure that no new change is ever uncovered. And the coolest thing about this all of this AI synthesis, validation, analysis, everything happens 100% inside your own environment. We're not a cloud-based solution. It's an on-prem tool. All of the analysis happens on the device where you run Cover. If we were in a room together today, I could do this demo completely offline on my laptop. When you run Cover in your CI, all of your code analysis is being analyzed in your CI container. None of your IP is being shuttled halfway around the world. You keep complete control on your code, complete ownership on your own code, but also on the test that we produce. So it all sounds really good, but who's using it? Well, all of the prominent and successful engineering companies around the world. They use Diffblue Cover to automate test writing and free up their developers to focus on more productive and more enjoyable activities, really. We have customers who've used Diffblue Cover to stop outages. So Cisco is a big case there where they had a high billing application, an IoT platform, processing 200 million IoT devices with more than a billion messages. And they used Diffblue Cover to write test cases for the applications to make them more resilient. And the result they found was there were fewer outages, and we caught unintentional behavior changes across 6 million lines of code. Goldman Sachs adopted Diffblue Cover to modernize a legacy application. Nobody wanted to touch that application because there were no unit tests written for it. So I'm sure a lot of people here can relate with that. The challenge to them was, it's a business critical application, has to be modernized. We don't know how it works. What do? They had deployed Diffblue Cover on that application, got it to write about a year worth of unit tests in a matter of hours. Those unit tests, as we've seen, because they reflect the runtime behavior of the code, so they are also really good at documenting how the application works, giving developers the confidence to go and start tinkering away at a legacy application which they don't really know much about. And finally, Raytheon had a similar case where they had to move a business over to the cloud in a very short time period, and without any unit tests for those applications, it was an impossible task. They again used Diffblue to write a bunch of tests for their 500,000 lines of code in the first few weeks of use, and were managed to make the transition to the cloud much faster and way ahead of their schedule. And the coolest, one of the coolest stories that we have is from Citi. So Citi Institutional Clients Group was under intense pressure from smaller, more nimble hedge funds that needed to innovate and deliver more quickly, but their legacy applications were preventing them from doing anything. So they needed to not just modernize, they needed to modernize fast, and they needed to modernize at scale. They adopted Diffblue and rolled it out to 2,000 developers across their organization, and immediately saw significant increases in team velocity, reduction in incident because no untested code ever made it to production after that, and overall higher developer satisfaction because developers weren't sitting there writing unit tests for all day. So we started off posing the question, is there a better way from what we have today? A developer human written test or LLMs? And we say that yes, with Diffblue, you can indeed move fast without breaking things. Diffblue cover writes human readable unit tests, which always compile and run. They always reflect the runtime behavior of the code, and they work without any manual intervention, which makes it a very nice fit for automation within your CI pipelines. And unlike other tools, which takes a few minutes to hours, it takes seconds. We wrote 82 tests in 4.5 minutes. That's about 3-4 seconds per test. That's how fast it is. So go ahead and try it on your own code.
Thank you, Animesh. That was excellent. I mean, basically, just to summarize what we've just gone through, Diffblue cover, we do need to talk about our own tool, but I will also talk about others in just a moment. And you have all very kindly given us feedback about which AI for developer tools you already know about. But Diffblue cover is AI with a difference. It's autonomous. It writes tests so developers don't have to. All code paths are tested, and unlike coding assistants, there's no manual prompting and reprompting and iteration around trying to get to suggested unit tests. Essentially, if you want to hand off unit testing, Diffblue cover is your solution. Diffblue cover also uses reinforcement learning as a method of machine learning, and therefore it's not LLM trained. And from a compliance and security point of view, there's a big difference there. And therefore also you won't have hallucinations. And Diffblue crucially can be used for inner loop testing and rapid code change developer feedback, as well as Animesh demonstrated. It can also be used at scale by development teams rather than individual developers in CI pipelines. And with that, I'm going to actually skip straight to our Q&A. And actually, the very first question that we have is from Dita Ebola. Thank you very much, Dita. And you have asked about really the developer stack. And it's very important that developers have developer tooling that fits with this stack, and you seem to be interested in Visual Code, Visual Studio. So Animesh, the first question is whether we have, Diffblue as a company, have any plans in the near future to actually support Diffblue in VS Code.
It's on the roadmap. We don't have a fixed date, release date confirmed yet, but we are looking at Visual Studio Code. We're looking at Eclipse, because these two IDEs are the two other big in the Java landscape that we live in after IntelliJ. So yes, it's on the roadmap, but we don't have a specific release date.
Yeah, I mean, it's really good to hear that come up, actually. And obviously, VS Code is probably the most ubiquitous editing tool, IDE, comprehensive IDE. And so Dita, it's on our radar. We are working on solutions for that, but as with every company, our roadmap and what's in it is has to be prioritized. So we'd like to hear from you if that is a priority, if that would make a difference as to whether you or your company would be able to adopt Diffblue cover, please drop us a line on marketing@diffblue.com, and we'd love to hear, you know, the difference that it would make to you. It would be me picking that up, and I'll be happy to get back to you, and I'll also feed that feedback to our product engineering team as well. We have heard that before. So I hope that answers the question.
What I would add is it still doesn't limit you from trying it out. So you can use the command line interface. It works on Windows, Mac, and Linux. And the GitHub integration or other CI integration works just as well. So it's not a limiting factor. I understand that the plugin gives you that extra developer experience while you're coding. But if you just wanted to try cover on your own code, you do have other options. I would recommend download the trial, try out the CLI. It's really cool.
So a number of interaction methods there. So we'll move on to the next question. It's from Adam Turner. Hi, Adam. Thanks for joining us. The question is, does Diffblue assume all code that is currently written is correct? That's a good one. Will it test assert a bug or incorrectly implemented behavior?
That's an excellent question, and it often comes up as well. We don't assume that the code is correct, because to assume something is correct, you need to know the intent. We do not know the developer intent because the only input to the AI model is the code that you have written. And that's also the reason why we don't catch bugs, because to catch bugs, you need to understand what was intended, and then you compare what's happening, and if they don't match, then that's a bug. So to understand what Diffblue is doing simply, because there's just no way for us to feed it that developer intent, the model that the Diffblue user experience has adopted is you give it the code that you want tested. It will go and analyze it and write a good, readable, reviewable test case for you. And then your code review stage, you look at the code change that you've made, you look at the test case, and that you need to review the test case. That's the human review point for what the Diffblue AI is producing, because every AI tool out there needs a review point. And for Diffblue, that's your code review process. So when you write a piece of code, and let's say there's a bug in it, Diffblue will write a test case demonstrating that bug, not because it knows that it's a bug, but because that's how the code works, and it just written the assertion that shows it to you. Now, in that code review, if you're not attentive enough, if you're not paying attention, and you do approve that, then yes, bugs will filter through. But that's why the code review process becomes very important. And if you're not doing your code reviews properly, then there are bigger problems than just code sneaking through unit tests. So long story short, we do not make any assumption about the intention of the code, because we can't. And so we will write the test cases based on the code you've given us. And then we trust the developer to review both the code and the test cases produced to make sure that the feature works as intended.
Adam, I hope that answers your question. If not, chuck us another one in the Q&A. Sergey. Sergey is interested in CI pipelines and is simply asking, does Diffblue cover work with GitLab CI?
Yes, we have an equivalent integration with GitLab that I showed you on GitHub. It's a very simple one-click integration. With our CI integration, if it's an environment that can run a command line tool, which all CI integrations can, then you can run Diffblue.
Okay. Yeah, as Animesh mentioned, GitLab, and we've most recently launched GitHub Actions, and so we've deeply integrated there. So we support a number of CI pipelines natively, and Diffblue cover can actually be, with a little bit of work, used with most popular CI pipelines, CI management tools. Okay, Sergey also is asking, does Diffblue know the application's business logic, and has the entire context within, and does it have the entire context within one application repository? I'll stop there. There's a follow-up question, but we'll come to that in a moment.
Yes, so we are looking when we analyze the application, we analyze the build bytecode of the application to identify all of the methods and classes that make up that application. How are they chained together? We call that data flow analysis. And how do they deliver the functionality they deliver? So unlike LLMs, we don't have a window that limits us from analyzing how much code we can analyze in one go, because we don't use LLMs at all. So our technology, very simple. We'll just go run your application. We'll observe the behavior, and we'll be able to observe both the side effects and effects of the code, because we run it in this special sandbox that we create. And then based on that, we'll write the test.
And Sergey also asked, what is the context size of the Diffblue model?
Ooh, to be honest, I don't know that.
I'm
And
not sure. That's a tough one.
I don't even think that applies to the model that we have, because again, that's a very LLM driven
Centric, yeah.
question. Yeah, we do not use LLMs internally. We use reinforcement learning. We use some fuzzing and a few other clever techniques to write the test cases that we do.
Okay. And Abjit Vida, I hope I've got close to your name, and thank you so much for joining us. Can you share more details of the application modernization use case? That's not specific, but I'm sure Animesh can elaborate and talk about it a little bit more. We can even go back to that on slide if that would be helpful.
Yeah, I can. So we do get a lot of our customers, particularly the ones in large financial services organizations, saddled with old legacy applications. And one of the biggest hurdles in modernizing any piece of code is do the team understand how it works? I used to do a lot of modernization work in a previous life, and until you understand how an application works, nobody wants to actually take it apart, because then when you put it back together, you can never put it back together the way it was. It's like when you're a child and you open your toy, you can never put it back together the way it was. So the thing that allows you to efficiently modernize an application is an excellent set of unit tests, regardless of who writes it. You need unit tests because that gives you the confidence that and an understanding of how the application works. And when you take it apart and put it back together again in a new environment, this unit test suite allows you to verify and validate that this new thing works exactly how the old thing used to work. So that unit test suite becomes very, very important. Now, the question is, who writes it? So a lot of the times people choose to do it themselves, and this is a gargantuan task which can take years. With some of these AI tools coming out, particularly tools like Diffblue Cover, which can work at scale in the CI, so developers don't have to sit there and edit test cases all day. This is a very natural and use case for our tool. So a lot of the customers will deploy Cover, target it at a legacy application, and let it write tests for 8-9 hours, 2,000, 3,000, 20,000, 50,000, however large the application is, those many test cases you get. But those 50, 60,000 unit tests that you get that make up the whole test suite give the company the confidence and the developers the confidence that they now can start taking it apart piecemeal, because this test cases that Diffblue has written will help them validate that whatever new thing that has written works exactly as the old one. And that's what the modernization use case is all about. So you can modernize, it could be a modernization just about taking an application as changing how it works. And it could be a deeper modernization where you take an old school monolith and break it apart into microservices or an event-driven system. The principle stays the same because the business logic remains the same. It depends how you deploy it. I hope that answers the question.
I hope it answers it too, and we'd love to hear from you about some of the challenges that you face in the real world about application modernization and why modernization is required, and some of the testing challenges that you have there. So please feel free to get in touch. We'd love to know what you're working on. Moving on, I really like this one because it's actually something that I'm working on with the product and engineering teams right now, and this relates to the actual generated test method names. So Jordan, welcome Jordan, thank you for joining us, has got a great question, which is the generated test method names, quotation marks, test, method name, and then number, could be more descriptive. Animesh, feel free to look at this question in the Q&A if it would be helpful. Would be more descriptive, for example, method name with input summary with output summary, so followed by output summary. So Jordan's asking essentially what's on the roadmap for generated test method names functionality. How we name our tests is something that we are looking at so that we can prove how developers can actually review the tests returned should they actually need to take manual intervention. Yeah, I'll pass over to you, Animesh, to add to that if you have anything to add.
Oh, we get this a lot actually, and a big reason for that is actually this is one place where the LLMs are really good. So LLMs, when they write test cases, they're generally really good at writing, naming the test cases very descriptively.
Yeah, and in a contextual semantic way.
Yeah, it's actually a surprisingly hard problem to solve. It's much easier to write a test case than to name it. And we have the saying in computing anyways, naming things is hard. So we are trying out a few different things, as Zoe said on the roadmap. We're even investigating if we could use LLMs in here to try it. So we'll see. It's something we get a lot of feedback on. And we do have some exciting changes coming up which should address these concerns.
Yeah, and I can say that I've seen some internal demos. We do have exciting changes coming up in the very near future on this. It's not an easy problem to solve, but in terms of our commitment to developer experience and just continuously working on two things, we're always working on trying to improve the accuracy of our test returns. We're certainly better than all other solutions out there, but it is something that needs continuous commitment to improve and improve and improve with complex code bases and just improving that. And then the second is, we do and are aware of AI assistants. They exist, and Diffblue cover actually sits very comfortably alongside them. Essentially, you'd use them for very different things sometimes. Certainly, we asked you in the survey, and some of you have been very kind enough to give us some feedback as to whether you're actively using AI development tools, and 67% of you surveyed tonight have actually said yes, 33% no. That's surprising, but I think if we ask that in a few months' time, that will change. And then we've also asked you which of the AI tools have you currently heard of? And in addition to Diffblue cover, all of you have heard of GitHub Copilot, ChatGPT, and I suspect are using them actively in your day-to-day development. And they are much more generalist tools that cover different languages and are trying to give assistance and suggestions across a number of different jobs to be done that developers have to do. Diffblue is specialist and specializes only on providing quality tests and comprehensive test suites, and I'm writing those tests for you so you don't have to, and that's quite a different use case. So if you want quick feedback and test suggestions, well then, LLM-based code assistants are very good at that. And there are other uses for those in your IDEs that are beyond what Diffblue cover does. But essentially, if you are either trying to to hand off unit testing completely with minimal manual intervention, minimal manual review, and minimal manual writing, well, then that is the problem that Diffblue is there to solve. To reduce that 30%, sometimes it's more like 40 to 50% of time, developer time spent on test writing and test maintenance. That's huge. And it's not what you all want to be doing. You'd be much better served actually applying your productivity towards building great apps, and that's what we are here to help you do. So essentially, what I'm trying to say there is that, you know, do watch out for a blog post and some more materials coming from us, because we'll be doing some direct competitor analysis and testing of Diffblue cover versus GitHub Copilot for unit test writing. And that will be coming out in the coming week or so, where we'll be directly assessing, and we've got an independent person that's worked on assessing the capabilities, the feature sets, and how much time they save developers. And so we acknowledge that you will still be using Copilot and various other tools for a myriad of other developer assistance that is needed and is intended to speed you up. So yeah, I think that is something that's coming from us soon, and I hope that you'll check back on our website to take a look at what an independent product evaluator has actually found when these tools are run head-to-head on the same source code, in terms of the capabilities of actually being able to enable developers to receive comprehensive and accurate unit tests. Okay, so I'm going to move on to Michael Young. Thanks for joining us, Michael. Michael's question, Animesh, is will Diffblue generate and be able to run tests for applications running under Tomcat or Wildfly?
Yes to Tomcat. I need to confirm with the product team with the other one, but yes.
That's short, and that's very, very sweet. So, and Michael, again, if you want to know more about that, please do reach out to us either on our community forum, or you can send an email to ask a more specific question to marketing@diffblue.com. And I'm going to put a call out there now. We've come to the end of the questions that we've received from you at the moment. So I'm just going to give you a minute or so. Do you have any further questions that we can answer live for you? In the meantime, while you're just thinking about that, I'd just like to say that in the webinar chat, we have actually shared some links with you. If you are not able for any reason to be able to copy and paste them, please go to our website. We do have Diffblue cover available in trial format and also our community edition. So we've got two flavors available for you. We've talked a lot. We've shown you, but the best thing really is for you to try it out for yourself. So I would advise you that if you are a professional developer and working in a team, it would be great to evaluate Diffblue Cover Teams Edition. And we have a 14-day trial available from the website, after which you can get in touch with us should you need to extend it. But that is available at diffblue.com/try-cover, and you'll be able to get to that there. If you are actually not a professional developer, if you want to use Diffblue cover perhaps for a non-commercial open source project, we'd love it if you did. We are there to serve the community, and we have a community edition available as well, which is available at diffblue.com/community-edition /download. But just a little bit of rooting around on our website, you'll be able to get to all of these, or you can just directly Google. But you are developers, you are curious. We'd love you to try out Diffblue cover directly and tell us what you think. We can only show you so much. But really it does transform one's approach to unit testing and certainly unit test writing, and it enables teams to actually unit test faster in CI. So we're all about making developers' lives easier. Animesh, do you have anything to add to that?
No, I would say go and try cover. If you use IntelliJ, try the IDE plugin. If you don't, try the CLI or the CI integration. They all work the same way. They all produce the same code and same tests. And get us in touch. Get in touch with us if you want us to give you a more personalized demo or want to talk about how cover fits in your workflow.
Great. Okay, well, we have no further questions. So some of you are probably still working. We really thank you for joining us this evening, this afternoon, and for some of you this morning. So thanks for tuning in. We have lots of other webinars planned, so please keep an eye, sign up for our newsletter, or keep an eye on our socials, and we'd love it if you join us again at some other time. We'll be diving into specific jobs to be done, as well as this sort of general overview product demo. So there will be various topics that we'll be tackling, and actually if there are any that you would like us to actually bring to a webinar, again, just drop us a line. We'd love to hear from you. And with that, I think that's it. That's a wrap. That's another webinar, Diffblue Cover 101 completed. Thanks all for joining us, and have a great day, a great evening, and a great morning. Thank you so much.
Thank you. Get covered.